Remaining part of the question number 5, function has the relative minimum at x equals to pi by 2. Put x is equals to minus pi by 2 in f double prime of x. We get f double prime of x is equals to minus 5 less than 0. So function has the relative maximum at x equals to minus pi by 2. As we know, if double prime of x is less than 0, then function will be have the relative maxima. So put sin x equals to 1 by square root 6 and double derivative of the function to get the value of the double derivative of the function. That is minus 10 over square root 6 less than 0. So function has the relative maximum at x sin x equals to 1 over square root 6, or function has the relative maximum at x equal to sin inverse 1 over square root 6. Put sin x is equals to minus 1 over square root 6 in double derivative of the function. We got f double prime of x is equal to 10 by square root 6, that is greater than 0. So function has the relative minimum at x equal to sin inverse minus 1 over square root 6. Question number 6. Function f of x is equal to a secant x plus b cosecant x, 0 less than a less than b. Given equation of the curve is this. As usual, we firstly we find the first derivative of the function, then we find the double derivative of the function, and then for stationary points put first derivative equals to 0, and then by putting the roots in the double derivative of the function, we find the relative maxima or relative minima of the function. So here we find the first derivative of the function, that is f prime x, a secant x and tan x. As we know, the derivative of the secant x is secant x into tan x, and the derivative of cosecant x is minus cosecant x into cot x. So this will become f prime of x equal to a secant x tan x minus b cosecant x cot x.